So the tutorial solution is already available on your Moodle, right? So this is probably the last tutorial of the semester. So there's only two problems for this particular week's tutorial, right? I mean, not two actually. There's a total of 5 problems for this week's tutorial. Some of them are actually repeated. So let's get started with them. Majority of them are theoretical questions, right? So problem number 1, list and briefly define 4 application areas of wireless LANs. So the first one is LAN extension, right? We use LAN to integrate with the wired LAN to extend the coverage area of the LAN complex, right? So we try to extend the range, right, of the LAN. Second is cross interconnection between the between two buildings. So for that we use LAN connection. For that we use wireless connection. The third is to provide the link between a LAN hub and a mobile data terminal, right? So that involves I mean, like, like the Wi-Fi that we use at home. So we have the internet connection and the mobile phone that connects, right? So that's the third one. The fourth one is an ad hoc network, right? Where in peer-to-peer network set up temporarily to meet some immediate need, right? So those are the four application areas of the LAN. Part B, list and briefly define the key requirements for wireless LAN, right? So when it comes to LAN, we are basically talking about Wi-Fi, so wireless LAN communications. So in that particular case, if you pay attention to the to your wireless LAN, or the key requirements for a wireless LAN is the throughput, right? The medium access control protocol should make as efficient use as possible for wireless medium to maximum capacity, right? We also, I mean, another requirement for a LAN is the nodes, right? The number of nodes it is going to be able to cater for, whether it is going to cater for, I mean, whether you are going to have one node with multiple devices connecting to it, right? Or you are going to have multiple wireless connections, such as in a USB setting where we have multiple cells where people connect to it, right? The second requirement is connection to the backbone. So definitely when we are talking about wireless LAN or when we are talking about Wi-Fi, we need the internet connection to it, right? So for that we need we need a backbone for it, right? And then for infrastructure, wireless LANs, this is easily accomplished. So it is easily accomplished through a control modules that connect to both types of LAN. So basically, when we are talking about LAN, when we have a LAN connection, we have a we definitely connect the LAN connection directly from the LAN port to the wireless LAN through a wired connection. So for that we need a for that we have a control module that connects the both types of LAN, right? Then there is a service area. The other requirement is the service area where the typical coverage of the wireless LAN would be in, right? And definitely when we are talking about the wireless LAN, we are also talking about the power consumption, about the devices. I mean, the Wi-Fi itself will be consuming some sort of power, right? So we are talking about the battery power consumption or the power consumption directly from the electrical source. Then we are also talking about the MAC address. I mean, right? The access point connection. This suggests that a MAC protocol that requires mobile nodes to monitor the access points constantly or encourage frequent handshakes between the base station, right? Typical wireless LAN implementations have features to reduce power consumption while not in use, right? So you might have seen when you're carrying the pocket Wi-Fi, what happens is there is a constant, I mean, there is a constant stage, like your Wi-Fi will make, I mean, have a power saving mode or a constant search with whether a device is connected to it or not, right? If the device is not connected, what it does is it typically goes in the sleep mode. So the Wi-Fi is disconnected. And most of the time, whenever you're getting the pocket Wi-Fi, or even if you are using a hotspot from another mobile. So what happens if a device is not connected to it? it turns the Wi-Fi off, right? So it is basically a feature of a wireless LAN, right? And then when we are talking about wireless LAN, we are also talking about the robustness, the security level. That is really important, right? When we are having wireless LAN, anyone can connect to the network. So it is really important that there is a robust security, right, embedded in it. So for this, most of the security systems use the passwords, right? There's a password, and then there's different types of uh, different types of secure connections that are available for the wireless LAN as well, right? So, and then collocated network operation as wireless LANs become more popular, it is quite likely for two or more wireless LANs to operate in the same area, in same area, or in some area where interference between the LANs is possible. So collocated network operation is when we are using multiple nodes, right? Such as USB. Like at home, you might be using just a single wireless service. I mean, single Wi-Fi device is enough. But when we are talking about university level, in order to provide the network or to cover the range, we have multiple access, right? So for that, we have to colocate the network operation, right? And then there's a license-free operation where the user would prefer to buy and operate wireless LAN products without the use of secure license for frequency band used by the LAN, right? So there is another feature or another requirement for the wireless LAN, right? I mean, it has to be license-free, because when we are trying to buy the wireless network or the Wi-Fi device, definitely, if it's license-free, then only we'll be buying it. Otherwise, what's the use of buying the device and then you have to purchase the device? I mean, purchase the license in order to transmit signal, right? So license-free operation is also another requirement that needs to be there in order for the clients to use it, right? And then there's handoff and roaming as well. So those are, and then there's also the dynamic and the static configuration of the IPs, right? So a dynamic configuration helps to secure the port as well, and it constantly generates a MAC address for network management aspects for LAN, right? Should permit dynamic and automated addition, deletion, relocation of and systems without disruptions to the user, right? So in a dynamic system, what happens is it keeps on changing the IP address. It generates a pool of IP address and configures it to each and every device rather than a standard IP address, right? So the dynamic configuration has to be there. Like for USB network, there's multiple people connecting, right? There's thousands of students who are trying to connect to the Wi-Fi, to the USB Wi-Fi when there's a normal standard classes going on, right? So there's multiple students trying to connect to the Wi-Fi LAN. So what happens is that if there's a static IP address given out to one individual, then there'll be a lot of data that needs to be stored, right? So what happens is in that particular case, dynamic configuration is used. There's a pool of IP addresses and that is generated and randomly assigned to each and every devices, right? So dynamic configuration is really important in that particular case, right? To limit the data use, to make efficient data and the for security purpose as well, right? So those are the key requirements of the wireless LANs. So you can go over them, right? There's a whole list and explanations over here. Next is, what is the difference between single cell and multiple cell wireless LAN? Single cell, like I said, single cell is the Wi-Fi network when we are using at home, right? There's just one Wi-Fi node and there's multiple devices connecting to it, right? So there's a single control unit at home. And when we are talking about multiple cell LAN, we have the one wireless LAN, but there's multiple stations, isn't it? So there's multiple ports. So in that particular case, we say that there is a multiple cell wireless LAN, right? So one, I mean, let's just say you get a Wi-Fi service at the when we are talking about the multi-cell wireless system, if you look at USB, you might catch the internet near the bus bay, and then there's a area where there's internet that is missing, and then you get the Wi-Fi coverage when you reach the OZ area, right? Again, you get the Wi-Fi at that particular placed. So there is another node that is placed over there that has the similar name, and it is basically connected to the same network. So in that particular case, we are having multiple ports. So in a multiple cell, there is a multiple control modules, right? So multiple Wi-Fi devices that are installed that are interconnected by wired LAN, and each module supports a number of wireless end systems within its transmission range. D, what is a caveat graph? A caveat graph. So in a caveat graph, it is a pictorial representation comparing along multiple variables, right? So let me just show you what a caveat graph is. Caveat graph. So you can see there's multiple variables that are compared to each other. So this is a caveat graph, right? So in a caveat graph, we basically compare multiple variables with it, right? And moving on to the next question. What are the key advantages of the infrared LAN? So remember, infrared waves do not penetrate the walls, but it does deliver faster internet, right? So it is unlike the microwave spectrum. So the first advantage is the spectrum for the infrared is virtually unlimited, right? Which presents the possibility of achieving extremely high data rates, right? Okay. The second advantage for it is that the infrared spectrum is unregulated worldwide, right? So there is no control in this particular field in this infrared spectrum. So when there is no control, you know what happens, right? When there is no control, there's a freedom to use it anywhere, right? And then infrared light is diffusely reflected by light colored objects. So what happens is when you have a coverage in a room, so if there is light colored wall, so what that means is that the signals will bounce through the walls, and then it will the signal strength will not diminish in that particular case, right? So whoever is in that particular room or in that particular area will get the most it will get the most efficient use of the signal strength, right? So thus it is possible to use the ceiling reflection to achieve a coverage of an entire room as well, right? So that reflection also helps to cover the entire room, right? Just in case in a room, the signal, a normal Wi-Fi might not be able to reach the person who is sitting at the end of the room, right? So what happens in an infrared system, it basically reflects all across the walls and it passes to the individual, right? And number 4, infrared light does not penetrate through walls or other opaque objects, right? So what that happens is it provides 2 advantages, right? When it's not able to penetrate the wall, it offers 2 advantages. That is that it can easily be secured, right? It is easily secured against a eavesdropping, right? Someone who is in the other room might not get the signal because it just it is contained, it does not penetrate the wall. So if you whatever happens inside the room, whatever you are doing, whatever searches you are doing through the internet, through the wireless communication, it happens within the room. No outsider can interfere into it, right? Whereas in a normal microwave or in a normal wireless system, what happens is when the signals are able to penetrate the wall, someone from the outside world is able to, has the opportunity, or there's some room for the other person to actually hack into the system, right? So it prevents that, right? And second, the separate infra installation can be operated in every room in a building without interference, right? Enabling construction of very large infrared LANs, right? Fifth, another strength of infrared is that the equipment is relatively inexpensive and simple. Okay. Part F, what are some of the disadvantages of the infrared LANs, right? So many indoor environments experience rather intense infrared background radiation from sunlight or indoor lighting. So this ambient radiation appears as the noise in the infrared receiver, requiring requiring the use of transmitters of higher power than otherwise be required, and also limiting the range. So the first one is that the sunlight and the indoor lightings, they emit infrared signals, so which tends to affect the infrared signals of the LAN. So in that particular case, it diminishes the power, or is read as the, I mean, it weakens the infrared signal. So for that purpose, the transmitters have to have higher power in order to receive these signals, right? Increases in the transmitter power are limited by the concerns of high safety. So again, the transmitter power cannot be too high, because um, infrared rays are actually dangerous for us humans as well. So the safety issue comes in that particular case. So that is why it is a disadvantage for the infrared LAN. G, list and briefly define 3 transmission techniques for infrared LANs. So these are basically transmitted. I mean, it can be actually focused or aimed at something, such as a TV remote, right? TV remote uses infrared signal, right? You basically can aim or focus the signal. It can be radiated omnidirectionally, and it can also be reflected from light color ceiling. Problem 2, for problem 2, compare and contrast the wired and the wireless LANs. What unique concerns must be addressed by the designer of wireless LAN network? So what happens when we are constructing a building? Um, we have to adhere to how the wires will be running when we are implementing a wired LAN, right? So the infrastructure is not that flexible. You have to actually make pathways for these wires to run through in order for the communication to take place, right? So there's a there's a physical limitation of this wired LANs, right? And so it says wired LAN becomes part of the location infrastructure and therefore less flexible in the maintenance and modification. However, the physical nature of the wired LAN makes it inherently more controllable, right? So if it's physically present, the signal, in what direction the signal is flowing. If there is some sort of fault or anything like that, you can easily detect it. Whereas in the wireless LANs, it is much more flexible in implementation, right? You can directly place the wired connection, and but require more complex maintenance mechanisms because they are more fluid characteristics, right? So wireless connections, just in case if there is some error or something like that, just because there is no path, um, a direct path or flow of the signal that you are aware of, right? So it becomes a little bit tricky in order to do the maintenance, right? So at times you might have noticed that the wireless coverage, whenever there's a wireless coverage, there's maintenance happening, you might be having the signal at the OZ lecture theta at times, right? But after a short maintenance, what happens is there's a shortfall of the signal, right? It constantly disconnects and connects and all those. So it basically increases the complexity of maintaining it, right? Unique concerns for wireless LAN designers include device power consumption, right? Quality and security transmission. So whenever we are talking about wireless communication, we have to ensure that the connection is quite secure. The licensing and other concerns related to the mobile nature of the technology. Problem 3, I think we have already touched on problem 3. Describe the 802.11 wireless LAN, right? So when we are talking about 802.11 wireless LAN, we are basically talking about the Wi-Fi system that is basically provided at home, right? Provides network connectivity over wireless media, right? An access point is installed to act as a bridge between the wireless and the wired network. So the 802.11 wireless LAN is basically the Wi-Fi system that is installed at home. So whatever you can think of is basically associated with your Wi-Fi. So it basically connects to the wired LAN connection, right? Definitely, whenever we need a wireless access point, basically the network, the modem basically acts as an access point to provide the connection to the wired LAN, right? And then it also extends range, right? So the range of the connections are also controlled by this, right? Depends on the structural hindrance and RF gain of the internet access point, right? So, and then there is the total of 3 types of 802.11 flavors that are 802.11b, 802.11a, and 802.11g. So these variants do have a little fluctuation, right? So that's regarding question number 3, right? Problem number 4. Describe the concept of multiple access with collision avoidance. So when we are talking about collision avoidance, what happens is whenever a sender tries to send a signal, it sends the signal to the receiver, right? So whenever you're trying to receive the call, basically a signal is sent to the receiver, right? So the sender sends a request to the send signal, right? So that is known as the RTS frame. So a RTS frame is actually is sent out by the sender if you want to make a call example to your friend, let's say. So basically, when you dial the number, you send out a request to the request to send frame to transmit the data, and then the receiver has to respond to that, right? So if you call your friend, if the line is clear, so in that particular case, there's a clear to send frame that is sent through, right? But if there's another call going on with a friend, right? If your friend is already on a call, so clear to send frame is actually not received, right? So in that particular case, I mean, when the clear to send frame is actually received or sent back by the receiver, right? When the line is clear, it is sent back to, I mean, that particular information is sent back to the sender so that the sender can send the data. If the sender does not receive this CTS frame back, what happens is it assumes, right, the request has not been accepted, or there is a collision that has been taken place, right? So receiver sends an acknowledgement. Just this is when the line is clear, right? So you send the RTS frame. The receiver has to send a clear to send frame back, so that you can start sending the data, and the receiver has to acknowledge whenever the data is received. But just in case if the line is not clear, or if there's some sort of collision, when the sender does not get a CTS back, right, a clear to send request is not sent back to the sender, it is assumed that there is a collision that is going to happen, right? So initially let's say you are the sender, you want to call your friend, so you send a RTS signal, right? That is to request to send a signal. So the receiver has to send a clear to send signal back to you in order for the data to be transmitted from the sender end, right? From your end, if you're trying to make a call, the receiver has to send information back whether the line is clear or not. So that particular, if it's clear, it will send a CTS frame back. So this once that is received, if it's clear, right? So the sender, the data, you as a sender, you can start making or transferring data from your end, right? Or let's say a voice call. If you're making a call, in that particular case, the data will be your voice call. So you'll send that voice call back to the receiver, and when it is received, an acknowledgement is received by the sender. Just in case, if the sender does not receive the CTS frame back, until it does not receive the CTS frame back, it is assumed that there is some sort of collision, or that line is not clear for the information to be passed through, right? So that is the concept of multiple access with collision avoidance, right? So there could be multiple senders that can be sending the information to the receiver. So this is the logical diagram that you can use to understand how the system works, right? Problem number 5, briefly describe the roles of the repeater, hub, bridge, and the switch. So repeater, what it does, it basically repeats the signal, right? Whatever signal you have to regenerate it, and it passes on, right? It basically acts as an extender, right? So you might have heard about Wi-Fi extender. You are basically trying to extend this signal range of that particular Wi-Fi signal. So in that particular case, what a repeater does, it is also an extender. It receives this particular signal and resends it, right? So if you are at home, if you are in one room and you are not able to receive that signal, what you can do is you can install a repeater, or you can also install a extender, right? Repeater could be also known as an extender. So whatever Wi-Fi signal is received by the extender, it is going to re-emit it or regenerate it such that the Wi-Fi signal is able to reach to that particular point, right? So a repeater basically receives the signal and regenerates it and passes it on. So these are the other frameworks. What a hub does is, hub is basically like a when you talk about a hub, it is the central part, isn't it? So multiple nodes can connect to that particular device. So when we're talking about the Wi-Fi acts as a hub as well, right? So multiple devices can connect to it. So hubs are used to connect multiple nodes to a single physical device, which connects to the network. So this a hub could also be your Wi-Fi device as well, right? Hub is the central part. So everything connects to your hub. When we talk about bridge basically, when you talk about bridge, we are basically connecting two items, right? So you have A, you have B. In order to connect those two, you can bridge this system, right? So a bridge is basically, it is used for logical separate network segments between two network, right? And then we have a switch. Switch is basically a bridge connection. However, it is now, I mean, when we have a bridge, we are talking about point A and B, and then you are connecting 2 points. When we have a switch, we are basically connecting multiple lines, right? When you talk about bridges, we are talking about multiple lines, right? So uh, let me show you a bridge and any switch. So bridge, switch, difference, right? Images. So let me just show you a switch and a bridge difference. In a switch, what happens is it can connect multiple devices, right? So if this system, I mean, if this computer sends a signal, you can send the signal to multiple devices, right? So it will tell you, okay, you're sending the signal to computer one. So it will send the signal to computer one. So switch basically connects multiple computers to that system, right? And then it redistributes it to multiple devices, right? So it can act as a switch. So you can switch between devices, multiple devices. A bridge basically connects one station to another set of station, right? One set of station to another set of station. Okay, switch and a bridge is basically that is the difference. Mm, another way of understanding is a bridge is a one, I mean, bidirectional, right? It connects two different connection points, right? Connection A and B. It basically connects network A and B. In a switch, what happens is it provides it to multiple people, right? So it switches, you can provide the information to a multiple person. So when we talk about switches are basically used in telecommunication lines, right? When you call, uh, a good example is when you call let's say, if you call SAS, right? And you want to talk to someone, right? And then there's multiple lines connected to that particular hub. So if you tell, okay, I want to talk to this particular person, and then the call is redirected to someone else. So in this particular case, a switch is used, right? So it helps to switch networks, right? It helps to switch, right? It helps to switch. So that a switch is used in that particular case such that you are able to switch calls between one user to another, right? That is the purpose of a switch. When you talk about a bridge, so you might have, let's say a bridge helps to connect two different types of network, right? Um, how can I tell you? Okay, let's just say a library network and a FST network, right? You are in the, okay. Let's just say you are in School of Engineering and there's another network at the School of I mean, at the library. So in order to access information of the library, it has to be bridged, right? So there is a bridge that is used. So bridge basically connects two things, right? And when we talk about switches, it connects multiple items to one place, right? So you can see switches are multiple port bridges. It is similar to bridge, but it is a multiple port. I mean, it can be known as a multiple port bridge. So the other informations are over here. So you can go through them. So basically this week's, the tutorials in the second half of the semester were basically all theory based, right? So make sure you go over all these theories. These theories are really important. I think the theory was also tested in your short test as well. So please be mindful be mindful to go over these theories, right? And what you write in your exam, it is really important. So apart from this, do you have any question? Do you need to know something that is missing from the tutorial that I might not have explained or I might have overlooked?
Still regarding the sample final exam portal on the model.
Yeah.
So we have to, can we attend that, or it's
Okay, let me
just
check. Let me just open it. So
there's
it's
a
open, it's visible. Okay, let me just
yes,
change.
it's visible. We can attend the question says we can attend the quiz, but I'm not really sure is the final exam or
Okay, let me. Oh, in that particular case, if it's a sample, you can do the attempt.
it's a sample.
Okay, if I go to the sample
It's
one,
week 14.
week 14. This is a sample final exam, so you can use it to like do your exam. So let me open it. So this will be at
It's the
yeah, you can attempt
it's
it. You can use it as a trial. You can just attempt it, right? It won't come in your exam or anything like that. So these are some of the questions, and if you want, you can attempt the quiz. So you can attempt it, right? There's 10 questions. You can go through them.
okay.
Okay.
So do you have any past year papers? Like there's only one on the model.
Okay. The thing is, going through the past year papers. Okay. First of all, wireless communication is, I think it is in its second or third year, right? So there's limited amount of resources available for this particular unit because it's a more recent unit offering, right? And then the second part is that since it's not a, I believe you understand that that it is now not offered face to face. At the moment, it is not offered face to face. So the questions will be slightly different. It will be open ended.
Okay.
You might have gone through this in your short test one. Remember in short test one,
Yes, sir.
you did not go through that question, but it did come in your exam. Something like that. Yeah. So it will be open ended. So that is why I would suggest be prepared for everything. Like whatever you come across, just be prepared with it. Okay.
Okay, sir.
Okay. So with that, we have concluded this week's tutorial, right? Make sure you go over that sample question. That is really important because whatever the paper will be, it might have a similar structure to that. I'm not sure,
Okay,
but
sir.
that might be the similar structure to it. Okay.
So okay, once I'll attend, if I get stuck to the questions, can I just...
Yeah, sure. I'll be able to help you out just in case
Okay,
if you
sir.
are not able to get the solution. Okay.
Okay,
Okay.
sir.
Okay. So yeah, with that we have come to an end to all the tutorial sessions, I believe. I'm not sure whether we will be having the tutorial, right? Just keep an eye on the tutorial in the week 14. If we do have another tutorial, then we'll be having the tutorial class. Otherwise, what I'm seeing at the moment, right? Let me just quickly see that 366. Okay, if you go through the Moodle page, I think this is the last tutorial, isn't it? This is the last tutorial. Next week we don't have any tutorial. Okay, week 13 we have a tutorial. That is week 12, right? Week 12 tutorial, and then we do not have homework 13. So yeah, this will be the last tutorial. Okay. Okay. So see, I mean like, oh, the other thing, prepare well for the prepare a good presentation for your project. It is due on next week Monday. Okay, so you
So
guys
what
have to
all is
present it
required in the presentation?
on a normal basic. I mean, like you'll be just basically presenting what you have done, how the simulation works, what you have identified, like no, in a normal presentation. How a normal presentation is, you have an introduction, you need to have an introduction. So basically you define why you have chosen that project and how it helps, like no basic introduction, right? A basic introduction. And then you'll be basically from there onwards, you'll be basically presenting your results, your findings that you have got, and then you'll be concluding what you have found out from your results, right?
So for the presentation, as I have submitted me and that Emmeline,
Yeah.
we just combine. I just placed हम खाली वो रखा रहा उनके result रखा रहा उसके discuss नहीं करा रहा सकता उसके edit
No,
करके
that's fine. That's
presentation नहीं
fine. That's
करा
fine. No, that's fine. Ooh, I mean, I could. That's not really important. I mean, I could just right. If you okay, if you
like
want, you can edit it. You still have got time. Okay.
खाली like introduction हम introduction रखा रहा
Mhm,
like advantage disadvantage और result और उसके conclude कर दिया रहा
हाँ हाँ
तो इसमें सकता edit कर लेना
हाँ edit कर देना. नहीं worry. Right.
okay okay
चल जी. I can give you that much time. Okay.
कितना मिनट के लिए मांगे presentation
It
roughly
will be around 10 to 15 minutes roughly. I mean,
10 to
let's try
15
to keep it under 10 minutes, right? Just a short presentation,
okay
10 minutes. Okay.
okay
Okay. Set. So with that, we come to an end to this week's tutorial and the tutorial session for all of this semester. So yeah. So have a nice day and bye for now.